Hey Mathville, here we go. Here's your test review for assignments 4 through 8. Do the best you possibly can because we don't want to have to do this again, right? Okay, the first thing we're going to do is use odd and even properties of our trig functions to find exact values. Okay, get ready to pause this if you need to. Alright, so we're going to have a little graph here and we're going to demonstrate odd and even functions. Okay, so this is a really sloppy graph of the cosine function. Please forgive that. But anyhow, it still demonstrates what we're talking about. If we're talking about t, positive t, to the right of the y-axis, and we say that is cosine of t is equal to y. Well, cosine of negative t is still equal to y because the graph is symmetric about the y-axis. So what we can surmise from this is cosine of negative t is the same as cosine of t. Their y values are going to be the same. That's what makes it an even function. Alright, so let's take a look at a different one. Let's take a look at a really sloppy sine curve. And the sine curve is not symmetric about the y-axis. As a matter of fact, if I look at sine of negative t, it's going to be negative y, and sine of t is going to be positive y, so they're opposites. So I can say the sine of negative t is equal to negative sine t. And that makes an odd function. Now if we talk about the tangent function has asymptotes. And the reason it has asymptotes is because tangent is sine over cosine. And so wherever cosine is 0, tangent does not exist. So we're going to have an asymptote. So the tangent of negative t, just if we want to go from negative pi over 2 to positive pi over 2, is equal to negative tangent t. Once again, one part is below the graph and one is above the graph. So tangent of negative t is the opposite of tangent of t. Alright, so let's work a couple of problems here. We're going to work cosine of negative pi over 4 and cosecant of negative pi over 3. Remember, cosine is an even function. So cosine of negative pi over 4 is the same as cosine of positive pi over 4, which is square root of 2 over 2, because we're in the first quadrant and you're supposed to have memorized your special angles. The cosecant of negative pi over 3, well, that is going to be the same as negative cosecant of pi over 3. Cosecant of pi over 3 is the reciprocal of the cosecant, of the sine of pi over 3. So that's going to be negative 2 over the square root of 3. Rationalize the denominator, you get negative 2 square root of 3 over 3. Now I'm going fast with this because I'm making the assumption that you already recognize that. If not, you need to go back and study that again. Okay, let's try another one. Let's try tangent of negative pi over 4. Tangent is an odd function. So tangent of negative pi over 4 is going to be negative tangent pi over 4. Tangent of pi over 4 is 1. So negative tangent of pi over 4 is negative 1. Once again, if you're having trouble following this, pause the video and go look at your unit circle. But I would rather that you look at your special angles and know where things are positive and negative. Remember, all students take calculus. Okay, let's use the periodic properties to find the exact value. Now, sine of 16 pi over 3. We know that the period of sine is 2 pi. So every time sine cycles around 2 pi, it comes back to the same thing. It's like being on the Monopoly board. If you are on Park Place and you go all the way around, you wound up in Park Place again. So if you're in Park Place and you go 3 times around the board, you're still on Park Place. or maybe Baltic Avenue. I don't know. That's the way I would do it. My luck. Anyway, so the sine of 16 pi over 3, I'm going to take 4 pi away from it. I'm going to take 2 revolutions of the unit circle, which would be 2 pi times 2 is 4 pi. So 16 pi over 3 minus 4 pi, but I have a denominator of 3, so I want to change my 4 pi to 12 pi over 3. So I have 16 pi over 3 minus 12 pi over 3 gives me sine of 4 pi over 3. That's something I can live with. Sine of 4 pi over 3, that's not in the first quadrant, so I got to figure out what's my reference angle. I know 4 pi over 3 is in the third quadrant because it's a little bit more than pi. 3 pi over 3 would be pi, so it's in the third quadrant, and it is a multiple of pi over 3, or 60 degrees. So I know the sine of 60 degrees is square root of 3 over 2, but the sine in the third quadrant is negative, and that's how I get my negative. So let's go on and let's do sine of 19 pi over 2. Well, once again, we have spun around the circle a number of times. So what I'm going to do is I'm going to make this 19 pi over 2 minus 8 pi. 8 pi is 16 pi over 2. I have to think in that mode. So 19 pi over 2 minus 16 pi over 2 gives me sine of 3 pi over 2. And the sine of 3 pi over 2 is negative 1. Let's determine the amplitude, period, and phase shift of some of our examples. So we have, in general, we have y equals a sine bx minus c plus d. Okay? So if I have y equals negative 3 sine 4 pi x plus 2 pi, that gives me, when I have a plus 2 pi, I have to remember that that is really a negative 2 pi. And that's why we talk about when we have a negative sign in front of c, it always makes it the opposite. So I have the amplitude is absolute value of a, which is absolute value of negative 3, which is 3. And that says how tall or how short the graph is. The negative tells you which direction it goes, and that comes up a little later. So the period of 2 pi over b, in this case, would be 2 pi over 4 pi, which is 1/2. So the period that this sine curve cycles through is going to go in 1/2, only in 1/2, not in 2 pi, not in 4 pi, but just in 1/2. The key points are the period divided by 4. So 1/2 divided by 4 is 1/8. So it's going to start somewhere, we don't know yet, but it's going to go in increments of 1/8 as it passes through the key points. The phase shift is c over b. We know that c is negative 2 pi and b is 4 pi. So the phase shift is going to be negative 1/2. And that means that instead of starting at 0, it's going to start at negative 1/2. Okay, so let's see how this works out. Here is our graph. We have negative 1/2. And because I am working in eighths, my period is in eighths, I'm going to change my negative 1/2 to negative 4/8, and that just makes it easier for me to count. So if I put some points on here and I start at negative 4/8, plus 1/8 is negative 3/8, plus 1 is negative 2/8, plus 1 is negative 1/8, plus 1 is 0. So my graph is going to cycle all the way through from negative 4/8 to 0. My amplitude is negative 3, and I'm dealing with sine. Sine will begin at 0. So I have, at negative 4/8, I have 0, and then negative 3, I will go down 3, I will come back to 0, I will go up 3, and I'll come back to 0. So if I connect my dots, there is my graph. Let's do another one. Let's do this graph. Now, with this graph, we have A, B, C, and D. We actually have a D, which means a shift up of 1. So the period is going to be 2 pi over B. B is 1/2, so 2 pi over 1/2 is 4 pi. So this is going to be a stretched out graph from left to right. Instead of going from 0 to 2 pi, it's going to go from 0 to 4 pi. The key points, if I take the period and divide it by 4, which is 4 pi divided by 4, my key points are going to happen every pi. So wherever I start, I'm going to add pi, and then pi, and then pi to it again. My phase shift, we have a phase shift here, and the phase shift is C over B, which in this case is going to be negative pi over 1/2, because I have it's plus pi, which is actually supposed to be minus C. So in order to make it a plus pi, it has to be a minus pi. So it's minus pi over 1/2, which is minus 2 pi, which means I'm going to start my graph not at 0, but at minus 2 pi. The vertical shift is 1, and we never graph the vertical shift until we have the entire graph graphed, the entire equation graphed, and then we shift everything up. So let's see what we need to do. Here is our graph, and we're going to mark off these positions. And we're going to start at negative 2 pi because that's our phase shift. And if we have to add pi each time, then that's going to give us negative 2 pi plus pi is negative pi, plus pi is 0, plus pi is pi, plus pi is 2 pi. So this gives us one entire turn of our graph. Now what are we going to do? Well, we have, that's 4 pi right there, from negative 2 pi to positive 2 pi gives us a period of 4 pi. Let's erase that. And let's put our y values, because we have an amplitude of bigger than 1. So, and we are talking about cosine, so cosine is going to start at negative 2, because the amplitude is 2, but a is negative, so we're going to start at negative 2, we're going to come to 0, we're going to go to positive 2, come back to 0, and then we're going to go back to negative 2. So if we draw our graph, and remember, this is not connected with straight lines, it's connected with curved lines. There is our first part of our graph. Now the only thing we have to do is shift it up 1. So we take each one of our points on our graph and we move it up 1, up 1, up 1, up 1, up 1, and then we connect our graph. So there's our total graph. Remember, graph everything before you do your vertical shift. Okay, next. Let's graph this equation. The period is going to be 2 pi over b, which is 2 pi over 2 pi, which is 1. Now, what I want you to remember as far as graphing, if you're given a graph that already has some points on it in terms of pi, you have to know, if you have just a number that doesn't have a pi associated with it, what does that mean? Well, pi is 3.14. So if you have 3.14, 1 is going to be just about 1/3 of the way to 3.14. So don't worry if you don't have a pi. They don't always have a pi with them. Pi means 3.14. 2 pi is about 6.28. So you have to kind of estimate. So let's erase that and let's talk about the key points. The key points is a period divided by 4. So it's every 1/4 or 0.25. The amplitude is 3. That's pretty easy. The phase shift is going to be C over B, which is minus 2 pi over 2 pi, which is minus 1. So we're going to start at minus 1. Minus 1 is about 1/3 of the way to minus pi, which would be minus 3.14. So kind of keep that in mind. Okay, so if you're given a graph that already has these values on it, how do you graph this? Well, the phase shift is -1, and minus pi over 2 is minus 1.6, and minus pi over 4 is minus 0.8. So your -1 is just a little bit to the left of minus 0.8 on your graph. Okay? And we are going in increments of 1/4. So if you start at -1, it'd be minus 3/4, minus 1/2, minus 1/4, 0. So you're going to do your graph between -1 and 0. There would be -1. There would be the next graph, minus 3/4. There would be minus 1/2. There would be minus 1/4, and there would be 0. So you're graphing between -1 and 0, but you have to put that on the graph that has radians on it. So there is what your graph would be of this function, one turn of this function. Phew, that's a lot to deal with. Okay, let's do one more. I'm going to give you a graph, and I want you to tell me what the equation of the graph is. Okay. Actually, you can do more than one equation, but we're not going to do it with any kind of a phase shift. So we're seeing that this graph starts at something other than 0, and it is either sine or cosine. So we're going to choose that it's cosine. All right. So we're going to say this is cosine. And since cosine of 0 starts at 5, we know that A is going to be positive 5. The amplitude be 5, and A is going to be positive 5. What's the period? Well, if I take a look from 0, where the top of the graph is, all the way down to 0, minus 5, and back up to 5, I see that it occurs in this amount of time. So I'm halfway between pi over 2 and 3 pi over 4. What is halfway between 90 and 135? Well, it's 120, which is 2 pi over 3. So my period is 2 pi over 3. And once again, take a look at this. That would be 120, but halfway between 90 and 135 is 120, and 120 is 2 pi over 3. So my period is 2 pi over 3, one complete turn of my cosine curve. Okay? So now the period is going to be 2 pi over 3 divided by b. So 2 pi over 3 divided, or 2 pi divided by b, b has to be 3. There's no phase shift that we have to deal with, and there's no vertical shift. So just taking the numbers that I know y equals 5, because I know my amplitude is 5, cosine 3, because I know that b is 3, and an x behind it. That's it, my friends. Good luck on the test. Signing off, the Fearless Teacher.